Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to YouTube channel Chandan Physics. In this video, we are going to discuss binary, half adder and full adder. Let's begin. In computers and calculators, arithmetic operations means addition, subtraction, multiplication and division. These are the arithmetic operations are one of the essential functions of computers and calculators. So, the logic gates can quickly within nearly equal to 1 microsecond they perform these arithmetic operations in case of any kind of electronic devices. So, the logic circuit basically used to perform these arithmetic operations are known as the arithmetic circuits. The logic circuits which perform the arithmetic operations are known as arithmetic circuits. There are so many arithmetic circuits, example as half adder, full adder, parallel binary adder, half subtractor and full subtractor, like this. In this session we discuss binary, half adder and full adder. So, half adder, that is a logic circuit used basically for addition purpose, addition of two 1-bit numbers. Remember, addition of two 1-bit numbers is known as half adder, and there will be no such provision of third input in order to add a carry. When we add two binary 1-bit numbers, so in input section let A is input, another input is B. So, the possible inputs when 0 is added with 0, 0, 1, 1, 0, 1, 1. So, the output we have two output, one is the sum, another one the carry C. When 0 is added with 0, we have 0, there will be no such carry, carry 0, 0 plus 1, 1, carry 0, 1 plus 0, 1, carry 0, 1 plus 1, that is 1 0. So, in that of sum column we have 0, and that of carry column we write 1. Look carefully to that of truth table. In that of sum column S, we have 0 1 1 0, whereas the inputs when 0 0 it will be 0 0 1 1 1 0 1 1 1 0. Either any of the input is low or high, then the output will be high. But when the two inputs are low, the output is low. When the two inputs are high, then the output is low. Means the output under that S column is high when either input, not both, is high. So that kind of truth table we observe when we are dealing with XOR gate. So for S column, say that is XOR gate. See that of carry C column, when the two inputs are high, the output will be high, otherwise it will be low. That is the truth table. AND gate, therefore for sum S is equal to, where we have 1 at that section 1, so we write the inputs for 0 as A prime, for B 1 as for B, plus another one we obtain here 1 0 A B prime. That result for what? That result A XOR B, that for the sum. Next, for carry C, here carry C and get result A and B, A and B. Now the logic circuit can be drawn by taking sum and carry. These results can be shown by using the logic circuit. For carry A and B, so draw AND gate, two inputs A B and output we have C carry is equal to A and B. Next, a XOR gate is used. It has the input A and B. Input A, another input B, the output we obtain, that is sum is equal to A XOR B. That one is the logic circuit. For what? For half adder. And in logic symbol we say this is a half adder. It has two inputs A and B as inputs, and outputs we obtain carry and sum. Two inputs and two outputs. Two inputs, two outputs. As we write, it has no provision for third input, that is a half adder. The logic circuit, logic symbol. For a half adder. It perform the addition of two 1-bit numbers. Since there will be no such provision of third input, that kind of disadvantage can be solved by using full adder, binary full adder, a logic circuit basically used for addition of 2-bit data, 2 data bits with one previous carry bit, resulting in a sum and a carry out, is known as a full adder. It has the provision for adding carry, unlike half adder. It has the provision to adding carry, but in half adder there will be no such provision to add a third input, but it has the provision to carry like that of half adder. As it indicates, it has addition of 2 data bits with one previous carry bit, means in input section we have 3 inputs and its result as a sum and a carry out, means output section we have sum and a carry. So in truth table, in inputs we have 3 inputs A, B and a carry in. It is represented by Ci, carry in. Next, in output section, same as a sum S and carry out CO. 3 inputs as 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. So the sum will be 0, carry as 0, sum 1, carry 0, sum 1 carry 0. Here sum 1 1 as 1 0. So in sum column we write 0, in carry column we write 1. Here sum 1 carry 0. Here 1 1 as in sum column 0, carry column 1. Same sum column 0, carry column 1. Here in sum column also 1, carry column 1. The inputs and outputs. In inputs, A is input, B is input, and carry in. In outputs, sum and carry out. It has three inputs and two outputs. Three inputs as one carry in. When we write the Boolean expression from that of corresponding truth table, Boolean expression from the truth table. So S sum S is equal to, where the result are 1 1, here 1 1 1, here is the 1, that's the inputs are 0 0 1. So in case of 0 we write the prime, in case of 1 we write it unprimed. So 0 as A prime, B prime, A prime, B prime, carry in, plus it is the sum of product terms. Next 1 0 1 0. So A prime, B, Ci prime, A prime, B, Ci prime, plus next one here 1 0 0, A, B prime, Ci prime, A, B prime, Ci prime, plus 1 1 1, A prime, B prime, Ci prime, sorry, A, B, Ci, there will be 1, A, B, Ci. Now I solve the Boolean expression rearranging the terms as A prime, B, Ci prime, plus A, B prime, Ci prime, plus another 2 as A prime, B prime, Ci, plus A, B, Ci is equal to, taking common as Ci prime, inside that bracket we have A prime B plus A, B prime, Ci prime. In these two terms we take Ci as common, inside that bracket A prime B prime plus AB as Ci common, A prime B plus AB prime, that is for A XOR B, to Ci prime plus A prime B prime plus AB, that is the A X NOR B into Ci. X NOR is the prime of XOR, so A XOR B Ci prime plus, that is the prime of XOR, so A XOR B, its prime Ci. From these two that is a b prime plus b prime a. That will be the definition of a XOR b, that the basics of a XOR b XOR c. So the sum can be expressed in Boolean expression by using that truth table. Next for carry out, that is CO. Look at the truth table. Here we have 1, so the inputs are 0 1 1. For 0 we have prime, for 1 unprimed, so a b prime ci, a prime b ci, so a prime b ci plus next one 1 0 1 a b prime ci, a b prime ci plus next one 1 1 0 a b ci prime, a b ci prime plus all are 1 a b ci, a b ci. In first two terms we take ci as common, inside that a bracket a prime b plus a b prime ci plus here a b as common, inside that a bracket we have ci prime plus ci prime plus ci, that will be 1. We have a prime b plus a b prime, a XOR b into ci plus a dot b. So for sum, that one is the Boolean expression. For carry out, that one is the Boolean expression. So the logical equations for sum and carry. Therefore, the logical equations for sum and carry out, can be written as S is the sum is equal to A XOR B XOR C. Next, carry out CO. Carry out, we have A XOR B ci plus a dot b, that for sum, that for carry out. Now by using these Boolean expressions we can draw the logic circuit for full adder. First we have to get S, A XOR B XOR C. XOR get, it has input, two input, let A B, so at output we have A XOR B. Next, use another XOR get, it has input A XOR B, another input C. So finally at output we have S is equal to A XOR B XOR C. So sum is evaluated by that logic circuit. Next, for carry out we take a AND gate. Having inputs it has two input A XOR B. One input is A XOR B. Another input is Ci. Here that is the carry input Ci. So carry input A B, that is carry input, that have expression, that is carry input Ci. So carry input set output here we obtain as A XOR B and carry input. Again another AND gate is used. It has two input A and B. One input A, another input B. So at output it is A and B. These two are the input towards a OR gate. So carry output here we obtain A XOR B carry input plus A and B. That one is the logic circuit for half adder. This is for, that is for full adder. So in logic symbol a full adder it has two input, three input A, B and carry input, two output as sum and carry output. It has input and output. The logic symbol of a full adder. In full adder we perform the addition of 2-bit data. Therefore, by using full adder more than millions of additions in a second can be performed. So instead of using that circuit, by combination of two half adders we can perform same actions, or it can also be made by using two half adders and an OR gate. When we use a half adder, let a half adder is used, half adder, it has the input A and B. So at output we obtain A XOR B and A and B. So A XOR B is the input for another half adder with the input carry in. For that half adder, the two inputs Ci and A XOR B. So at output, one output we obtain A XOR B XOR carry input, that for sum S. Next we obtain A XOR B and Ci. These two are the input towards a OR gate. So at output of that of OR gate, C carry output as A XOR B carry input plus A dot B, A dot B. So instead of using that circuit, we can also get a full adder by taking two half adders and an OR gate. We have sum and carry output. So with the help of this video lecture, we understand binary half adders, half adder, truth table. From truth table we draw the Boolean expression, then the logic circuit, logic symbol of half adder. The disadvantage of half adder is fulfilled by taking full adder. The performance of a full adder, this is a truth table, Boolean expressions. By using these Boolean expressions, we construct the logic circuit for full adder, is the logic symbol of full adder, and again that logic circuit also be created by using two half adders and an OR gate. This is a full adder. So with this useful and informative notes, let me wind up this session. Thank you.